The ordering cost, or sometimes referred to as setup or changeover cost, is related to the number of orders per year, R over Q. R is the annual demand. So R over Q gives us the number of orders per year. The annual ordering cost, therefore, is the number of orders per year times the cost per order. In this case, R over Q is the number of orders per year times S is our ordering cost, and that is 31,000 for this example, 31,200 over Q times $130 per order. So it's 4,056,000 divided by Q. This is the annual ordering cost function. And if we look at the annual ordering cost function here, the graph, we see that the annual ordering cost has a nonlinear relationship with our order size. The total cost function, the total cost is the annual holding cost plus our annual ordering cost, or Q over 2 times H plus R over Q times S. This is the annual holding cost, this is the annual ordering cost, and for this particular example is 0.45 Q plus 4,056,000 over Q. As mentioned before, Q represents the order quantity in units, H is the holding or their carrying cost per unit, R is the annual demand, S is the ordering cost, and if we take the product cost into account, so this is our annual demand times the cost per unit, RC is the product cost included in the formula. And if we look at the total cost function graph, we see this is a nonlinear relationship as well. If we superimpose all three cost functions, we see that if the horizontal line represents the order quantity Q and the vertical line represents our annual cost, this is annual holding cost, annual ordering cost, and this is the total cost function. Where is the total cost function is minimized? If we observe on this graph, we see that the total cost function, the dashed red line, is minimized somewhere in this approximate area. If we can find the Q quantity associated with that value here, then this is the quantity at which the total cost function is minimized. If we work this out, we find that the optimal quantity, the economic order quantity, equals to square root of 2SR over H. So if we solve this and substitute for the example where the ordering cost is $130, the annual demand is 31,200, and all of that over our holding cost, which is 0.90, that gives us an optimal quantity of 3,002 units. What that means is that the value in this, to minimize our total cost function, this Q is 3002. That every time we place an order, if we place an order for 3002 units, that would minimize our total cost function. So the optimal quantity is 3002 units. That gives us an average inventory of Q over 2, or 1501 units. The number of units, the number of orders per year is 31,200 divided by our order size, approximately 10.4 orders, gives us a total cost function of 0.45 Q plus 4,056,000 over Q, and we solve that. We have an annual holding cost of $1,350 and an annual ordering cost of 1,351, these two values are very close, almost equal to each other, for a total cost of $2,702. This is the minimum cost. If we place an order for 3,002 units, that would minimize our total cost, and it is $2,702. As you see here, this happens at the point where the annual holding cost and the annual ordering costs are equal. You can easily observe that in our graphs. This is the annual holding cost, this is the annual ordering cost. As you can see, that it occurs at the intersection of these two costs.